Hi everyone and welcome back. We're going to be looking at examples for the law of sines and cosines, and I'm just going to go over the slides that we looked at before so that we refreshed back in trig mode for you guys. I added a couple things in a slightly different color so you can see what happens, and I fixed one thing. And so let's go ahead and take a look at that first of all. I want to point out that the material we're covering is in our textbook. You find it on the textbook link on Blackboard, and you open up, that's our OpenStax, our free textbook. And in our free textbook, chapter 10.1, 10.2 are the laws of sines and cosines. And we're going to look at those today, okay? Now, remember the very first thing, there's other ways you could do this, but this is the most efficient way. The first thing you want to do when you're presented with a general non-right triangle to solve is to figure out whether you're going to use the law of sines or the law of cosines to get yourself wedged in. And the answer is you look for an opposing pair. Use the standard grid, they show up right across from each other. That's how that works. So if you see an opposing pair, that means you're looking at something for the law of sines. And otherwise, you can be using the law of cosines. Now, another way you can look at it is that if you have one side only, if you're only seeing one side length, that means we're going to be looking at law of sines. If you see three sides, that means we're going to have law of cosines. It's only when you have two sides that you have to make the decision between law of sines and law of cosines. And to tell which one it is right there, once you look for the opposing pair, right? Now, the law of sines on this case is going to be ambiguous. You never get any ambiguity in the law of cosines because at the very worst, you're going to be looking for arc cosine of some ratio. And because the arc cosine goes back to the cosine, which is an x thing, we know its domain, and hence the range of the arc cosine is x, first and second quadrant, everything from 0 to 180 degrees. So any one cosine that shows up in your formulas here is going to relate to one triangle. The law of sines, well, because it's a y thing, the answers naturally come back in the first and fourth quadrant. So if you get something with you're going to be tossing a positive number in, you're going to end up with an acute angle that has the same sign as its supplement, has the same sine ratio as its supplement, and that would be a possibly create a second triangle. And that's what's happening in the ambiguous case, because you'll end up solving for the sine of the angle, and that sine of the angle goes back to two possible triangle angles. And that's what creates the ambiguity. But again, what you'll be looking for is to see if you have an opposing pair. You can't get that. You can't get opposing pair if it's side angle side or side 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 if you don't have an angle. There's two ways to get an opposing pair for the law of sines, either directly or indirectly because you've got two angles, which tells you there's a third angle out there. Okay? Again, material is covered in our textbook, our open source textbook, our free textbook, OpenStax, if you want to read up on that as well. Okay, now, beyond that, the basic flowchart, opposing pair use law of sines, otherwise use law of cosines. I showed you a quick proof because it's kind of fun to do that every once in a while on how the law of sines works. But remember the law of cosines works. But remember the law of cosines is just an extension on the Pythagorean theorem, where instead of just a squared plus b squared, you have minus 2 a and b that you see here, the other two sides, times the cosine of the angle between them, which is the angle that's opposite the side c. Minus 2ab cosine c. If instead you're going to solve for the cosine, in the case where you're given three sides and you're looking for an angle to get yourself wedged in, It'll be a squared plus b squared, the two that you have, minus c squared, the third side, the one that's opposite you, not necessarily hypotenuse, not like the biggest side necessarily, over that 2ab. So these two swap, then divide by 2ab to get the cosine. And then you'll find the angle by hitting the arc cosine of this quantity. I just think it looks prettier this way. Okay. Remember, this is true. This isn't just a C thing. You can work with this to solve for any angle or side that you're showing by using the symmetries. In general, any side squared is the sum of the other two squareds minus twice their product times the cosine of the angle that's opposite the side. Now, when I wrote the symmetries, working the altitude form, I call this the altitude form. I call this the triple form. And you don't actually use the triple. You end up solving it using the altitude form. But this is so much prettier. This is the way it gets presented. Last time I was showing you how to do this by just cycling A to B to C, B to C to A, B to C to A to B to C. And I wrote these two incorrectly. And I noticed that in my notes as I was going over them later. And I fixed it now. Okay, so that's going to show up in the final one, because I'm just going to overwrite the previous file. So you're not going to get two files, notes for these two sessions, you get one big one. That's how it's going to work. Okay, and again, these are the cases. This one is the one where you have two opposing sides. And if you have opposing pair, a side and an angle, the third piece of information that's missing is either going to be another angle, in which case you'll have all three angles, because the angles add up to 180, and so there's no chance for an ambiguous case. The ambiguous case happens when you only have one angle, which means this other second angle that you would normally solve for, you're going to solve for the sine of that angle, and there's two possible solutions. An angle that's acute that comes out of your calculator, and its supplement, 180 minus that angle, is also a possibility. And we'll check the case on how to do that using our flowchart. If we have an opposing pair, we identify the opposite side and check to see if it's the one it's bigger than the adjacent side. If that's the case, whether the angle you have is obtuse or not, you'll get one triangle. If the angle is obtuse, and that's not the case, well, you're not going to be able to get a solution at all. So we're going to check the opposite against the adjacent, and we're going to check the opposite against the altitude. And the altitude, again, is really easy to figure out, because for any one spot, where am I? Yeah, for any one angle that I'm looking from, the altitude is an elevation, and elevation is sine. And you scale it up times b. So it's b sine a for the altitude looking from this side, and it's a sine b looking at the altitude from this side. And that's the equality that underlies the law of sines. But again, what's happening here is you have an angle, but you only have one side, one adjacent side next to it. You know what the angle is, but you don't know how long this is. You know how long the opposite is, but you don't know exactly what its orientation is. So I left it hanging. And in general, I can let that swing freely, and it's going to hit this third side, if it hits that third side, in two places. That's if that other side is greater than the altitude. If it's also greater than the adjacent side, the second place it hits is going to be outside the triangle. In the other case, where the original angle is obtuse, if I let it be free to swing, it has to be greater than the adjacent side. It's not enough for just to be greater than the altitude, because if it's greater than the altitude but not bigger than the adjacent side, the two places that it's going to hit are both going to be outside the triangle. And in any case, if it's bigger than the adjacent side, the place that it hits, the two places it hits, one will be inside the triangle and one will be outside the triangle. And so the obtuse case, it's only possible to get one angle out of this. Now, if it hits on two spots with an acute angle, these are the two possible angles that you get. The one that's going to come out of your calculator is going to be the acute angle. Okay, because your calculator answers in the first or fourth quadrant. And because you'll be plugging in positives, you're going to get an answer in the first quadrant, which is acute. Angles less than 90. But now, by the symmetry here, this angle is going to be the same as this angle inside this isosceles triangle that's made up by letting it swing, which means the other possible angle that gives you a triangle, you've got two possible triangles, this one and this one. And this second angle, B2, is going to be obtuse. And it's going to be the supplement of the original. Now, I want to point out again that this angle is acute. This implies the other one's going to be obtuse. So you get one angle. That's okay, Luis. It's fine. Yeah. You can have one angle that's acute and one angle that's obtuse. And remember, guys, even if you end up showing up a little late or you have connection problems or whatever, these things are going to show up on YouTube later, and you can pick up the piece that you missed there. All right? There we go. And again, remember that if you got two angles, B1 and B2, and one's the supplement of the other, they're going to have the same sign. And that's what's causing us to have the issue. We're solving for the sign of the angle, not just the angle. So, let's hit these first of all these examples. And right now, what I'm going to ask before we try to solve anything, I want to know whether this is a problem for the law of sines or the law of cosines, okay? And if it's the law of sines, I want to know if it's the ambiguous case, okay? So my first question is law of sines or cosines. And my second question, if the answer is law of sines, is ambiguous or not ambiguous, okay? So I'm going to flash through all of these examples. I'm going to, yep, that's right. This is for law of sines because we see an opposing pair, right? Let's look at this next example. Law of sines or law of cosines? Everybody type 1 for law of sines, 2 for law of cosines. I have 10 students in here. I want to see 10 answers. 1, 2, 3. Thank you, JD Anthony. 4. Thank you, Mario. 5. Thank you, Vinaya. 6. 7. Thank you, Elizabeth Randy. 7. I'm missing 3. 8. I think. Yeah, okay, I was up there. I think I caught that, didn't I? Yeah, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, I got 3. 8, 7. Yeah, I got 7. That's all I'm seeing is 7. 1, 2, 3, 7. I've got 3 students who are kind of here but not listening to me. And I kind of like, guys, really, I need hi, hi, hi. What am I going to do to get this guy's attention? Because what I'm really afraid is people are just kind of joining on here and then they're going off and doing their own thing. And they're not actually here. And the reason I think that is because at the end of some of these sessions, I have to remove people from the line because they're not saying goodbye or anything like that. They're just hanging there. And so I'm really concerned that I've just got students that are kind of logged in here. 1, 2, 3, 4, 5, 6, 7, 8. I've got 2 students who are just not even answering me right now, which makes me think that they got the browser open, that's it, and then they're just not actually in the class. That's disturbing. Oh. Okay. That's, I mean, free country. But it's this sort of thing that makes it very, because I'm so concerned on all my students, that I'm able to help out all my students that, you know, people that playing that game, bringing in the browser and then just not actually being here, that's a problem. I got 2 students who aren't actually here. They're just like showing up as participants. Okay, how about we do this? Okay, see, guys, if you're here, raise your hand. If you're here, raise your hand. Okay. Well, that kind of says it all. Anthony, are you here? Anthony, are you here? Miguel, I know you're here. Why don't you raise your hand? Okay, Anthony? Yeah, okay. Raise your hand. Daniel, are you here? Daniel, are you here? Daniel, are you here? Okay, maybe if I remove him from the session, he'll get the idea that there is something weird happening here. Miguel, are you here? Not Louis Miguel. Miguel. Miguel, are you here? Miguel, are you here? Okay, so if I remove him from the session, that's the idea. Maybe there's something weird here going on. But I mean, yeah, so I pulled them out of the session, and maybe they'll notice, and maybe they won't. I don't know. Okay, you can drop your hands, guys. I got 8 people. I got 8 people answering. That looks like it's going to work for me. Oh, that works fine. Y'all can lower your hands now. That's great. Thank you, Vinaya. Thank y'all. Okay, so the 8 people here who are actually here, so that's cool. And the 2 people I kicked out, I think they were not. Okay. So let's continue. And I'm not going to worry about the other 2. There we go. Okay. Now you had a question. Maybe, I don't know. Okay, that's good. Okay, how about this one, guys? Law of cosines. Law of sines, law of cosines. 1 for law of sine. I want to see 8. 1 for law of sines, 2 for law of cosines. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Who's missing on this? Come on, I want to see everyone. I want to see everyone. We try to figure out something. Randy, Anthony, Maya. Oh, Louis. Thank you, Louis. Yeah, everybody participating here. Just from my own peace of mind, okay? Yeah. This is law. Now, next question. Ambiguous, not ambiguous. Oh, I know you got issues. That can happen. I'm breaking up. Okay, I need to know if that's just your connection or other people. Am I chopping for guys? If I'm chopping, guys need to tell me on the chat because I'm not going to be able to tell otherwise. For you too? Sometimes? No, not for you, not for you? A little. I don't know. Some people it's okay. I'm just going to try speaking slowly and hope for the best. Because I know sometimes if I just wait a few minutes or wait a few seconds, the congestion clears up, and then we are. So this one, guys, ambiguous, not ambiguous. You tell me. 1 for ambiguous, 2 for not ambiguous. Yeah, and I did a kind of a cheaty thing on that, guys. Ambiguous, yeah. Ambiguous is for 1 angle. Not ambiguous is 2 angles. So if you see opposing pair and 2 angles, it's not ambiguous. And if you see 1 angle, then it's ambiguous. Okay. This one, law of sines, law of cosines. 1 for sines, 2 for cosines. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Law of sines, law of cosines, guys. Is there an opposing pair? Law of sines. No opposing pair? Law of cosines. Also, there's 3 sides. That tells you. Okay. I'm not going to get everybody's answer. Okay. Let's go on to the next one then, okay, guys? And thank you, guys. Thank you, JD and Elizabeth, and Benaiah, Mario, Anthony, and Randy, and Joshua. You're the best. Okay, how about this one, guys? Law of sines, law of cosines. Law of sines, law of cosines on this one. Yep, 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 yep. That's awesome. Ambiguous, not ambiguous. 1 for ambiguous, 2 for not ambiguous. Yep. And it's kind of nice because ambiguous cases is when you have one angle. Yeah, cool. Let's look at this one. Law of sines, law of cosines. Yes, Joshua, what's your question? We're going to be solving these after a bit. I'm just running through.
All right, hey, I'll text.
What's going on? Oh, you're okay. All right. So this one, law of sines, law of cosines, guys. 1 for sines, 2 for cosines. Oh, I couldn't fool you guys. I fooled you twice last time. It's not going to happen again. Up, this is Elizabeth. Elizabeth, the reason this is law of sines is because this third angle, the one that's across from the 15, we actually know. We know this one because we got the other two angles. So it looked like we didn't have an opposing pair, but we actually did. And we actually had an extra opposing pair because all three angles were implied. Does that make sense? Oh, and there's Patricia coming in now, too. Okay. Yeah, all right, that's cool. Okay, so that's why. This is law of sines. Okay, and again, I think Patricia did. Patricia, I'll have the video up on YouTube about an hour or so after the lecture, and you can catch the things that you missed. Right now, we're going through and checking to see, I'm checking to see, make sure everybody knows whether to choose the law of sines, the law of cosines, and if it's the law of sines, if they can figure out whether it's going to be an ambiguous case or not. Now, this one, 1 for law of sines, 2 for law of cosines. Everyone, you too, Patricia. Can you type on your phone? I don't know. Can you type in the chat box on your phone, guys? I don't know. 2, that's right. Yeah, yeah. Because this one could have been ambiguous because it's 2 sides, but you don't have an opposing pair, so it's law of cosines. Yeah, that's right. Okay, so you can type on your phone. That's great. Great. Okay. Patricia, we had a laptop for you, and I don't know what happened with that. Could you write me and let me know later and let me know what the situation is on that? Because I know I have at least one student. We were able to get a home delivery on those, and if it's a question of if it's just a question of transportation, we can make it happen. Okay? You weren't. Yeah, I had. Yeah, and so we'll go ahead and figure that out. Okay. All right. So anyway, this one's law of cosines. So how about this one, guys? Law of sines, law of cosines. 1 for sines, 2 for cosines. One. Ambiguous, not ambiguous. 1 for ambiguous. 1 for ambiguous. 2 for not. Yeah, that's just too easy for you guys now. Okay. Okay, how about this one, guys? Law of sines, law of cosines. Everybody says ambiguous, not ambiguous. 1 for ambiguous, 2 for not ambiguous. Which is it? Okay. That's great. That's lovely. Awesome. Thanks, guys. Yeah. So on this one, we'll be talking about this right here. This is my little thing trying to get you guys to a point where it takes you almost no time to figure out which tool to pick up. Okay? And hopefully this will put you in a position where you can answer the question, at least this much, know which formulas you want to be using just immediately. What will often happen is you'll have to actually plug in the numbers into the grid and then look at the grid. But as soon as you got the grid set up, there it is. It'll come out nice. Okay. Now how about this one, guys? Law of sines, law of cosines. Law of sines, law of cosines. Yep. Yep. Anything special you notice about this triangle, guys? This is a special kind of triangle. Which is it? What is it? This is a special kind of triangle. What is it? What do we call this triangle? Yes, this is an isosceles triangle. You see, two sides are the same, and that means the angles that are opposite them will be the same too. So once you've solved for one, you can solve for the other one. How about this one? Law of sines, law of cosines, guys. That's right. Okay. Now this one I tossed in as another special example. Look at those numbers. Look at those numbers. And I got gold star. Gold star for the first student who can tell me what's wrong with these numbers. Any ideas, guys? Gee, what could possibly be wrong with the numbers? I don't know. If you can't figure it out, we might have to use formulas that show up. Okay. Let's use formulas. Let the problem show up when we're doing the problem. Well, it's not a right triangle. It's not a problem. Because remember, this is Randy. This is not going to be a squared plus b squared equals c squared. This is c squared equals a squared plus b squared minus 2ab cosine c. Okay? On this one, because we don't have, remember this is law of cosines, right? Because everybody's decided this is law of cosines. So we all know this law of cosines. And the law of sines comes in two forms, right? And the two are either going to be c squared is a squared plus b squared minus 2ab cosine c, or cosine c equals a squared plus b squared minus c squared over 2ab. Now, first form rate if you got a and b and c and the angle c. And the second one's great if you got sides. So we're going to be using the third one, the second one, right? Okay. So, looking at for this one, we're looking for a. Cosine of a is going to be 5 squared plus 10 squared minus 3 squared over 2 times 5 times 10. And I went and plugged all the numbers faster than you normally. But here was looking at it the easy way. Okay, I know I'm looking for A, and so I'm going to look for the other sides. Square plus square square over twice the product. Let's see what that comes out. Okay, let's see what that comes out. 5 squared is what, guys? 5 squared is what? 5. And squared is 100. So it's 125 minus 9. What's 125 minus 9, guys? 125 9. It's 16 over 100. Right? Times 10. Times 5 times 10. Yeah. Does that look wrong? I mean, first good, guys. Tell me, is my arithmetic working? I was looking for a, so this needs to be b squared plus c squared minus a squared over 2bc. Yeah? You think a2 is supposed to be 3, not 5. Now remember, a is going to be the other 2 minus, this is for cosine A, and it's over twice the other 2. That's how this works. Okay, yeah, right, because that's how it works. Did I plug the numbers in right, guys? Yeah, yeah, so it's the other 2. And you don't, and really when you're doing these, you're not actually thinking what's A, what's B, what's C. It's the other 2 squared minus this square over twice the other 2. That's how it works. Okay? And then you don't have to worry about like which formula to work with, right? Now, look at that ratio. Did I do the numbers right? It's 116. Everybody said that was 116. Is 2 times 5 times 10 100? Okay? Now, let me ask again. Does anybody see a problem with this yet? It's going to be a silver star this time. If you can see what the problem is now, it's a silver star. What is it? Anybody see the problem? No? Yes? No? No? Yes? No? Okay, calculator time, guys. Calculator time. Everybody get your calculator out. Everybody get your calculator out. I want you to find the arc cosine, okay, of 116 over 100. Arc cosine of 116 over 100. Okay, somebody tell me what the arc cosine of 116 over 100 is. Error. Any particular kind of error, Joshua? What is it? What kind of error does your calculator say? It says domain error. You know what domain is? That's the thing that you plug in. It says there's a problem with the number that you tried to plug in. 116 over 100, what is that? That's 1.16, isn't it? Is 1.16 a valid ratio? Oh, no. Cosine runs from -1 to 1, doesn't it? 1.16, that's too big, isn't it? What it's saying here, yeah, it's bigger than 1. What it's saying here is be able to make this into a triangle, you have to get bigger than 180 degrees on that thing, on that angle A. You can't get there without like an angle that's bigger than 180 degrees. And you know why that happened, guys? Look at the 2 smallest sides. What do they add up to? What do the 2 smallest sides add up to? What's the biggest side? Do you see the problem here? If I use the 2 smallest sides, I try to stretch them out across the biggest sides, they're not long enough. This is called the triangle inequality. For angles, for sides A, B, and C, where C is the biggest, A plus B has to be greater than or equal to C. The 2 smaller sides have to be bigger than the 3rd side, or you can't get a triangle out of it. Now, if you notice that, you get a gold star. And if you'd noticed that 116 over 100 was too big, you get a silver star. And then when you plug in the calculator, it tells you there's an error, and recognizing that's real. The problem is with the problem, the numbers that you were given, and not with your math. That's when you see the bronze star. And if you give up and say, I just don't understand, then you don't get a star at all. You actually get the problem wrong. Yeah. Bronze star is good, but next time you'll get a gold star, I'm sure. There we go. Okay. So this is not possible. This is 1.16, which is not in the domain of the cosine function. So you can't do it. You found the button. That's cool. Okay. All right. So let's back up. Okay, guys. Law of sines, law of cosines, ambiguous, not ambiguous. Law of sines, law of cosines. Guys, which one? On this one. Whoop. On this one. Law of sines, law of cosines. You tell me. Law of sines. Very good. 1 for law of sines. Now, 1 for ambiguous, 2 for not ambiguous. Which is it? 2. That's awesome. That's awesome. So we're ready to go, guys. Now, here is how you do this. You come crissy-crossy, this way, and you take the signs of these things, and that's what the equation is, okay? So your equation here that you're going to solve for for C here, and this time, okay. So what you write here is C sine B equals B sine C. And this right here is kind of like you got B and C here. And I don't know if one of them is acute or obtuse here, but here's the altitude. And the altitude here, H, is C sine B is B sine C. You don't necessarily have to do that, know that to solve the triangle. You can just kind of like just go immediately to the C sine B, the crisscross with the signs. Okay, so let's plug numbers in now. Okay, guys? And now here is my advice. Never plug numbers in until you're actually where you're trying to solve, because that gives you too many chances to copy things wrong. So I'm going to write this as C times B. C is equal to B times C times sine C over sine B. And now I'm ready to plug things in. B is 5. Sine C is sine 75 degrees. And this is sine 20 degrees. And that's going to give us a length for sine C. That's going to give us length C. So everybody into your calculators now. 5 sine 75. Remember to close the parenthesis after 75 on your prefix or your infix calculators. Okay, Daniel, don't worry about losing connection because that's going to happen with you guys. I know that. Yeah, I know that's going to happen. You lose connection and stuff. Because anything you miss there is going to show up. Anything you miss is going to end up showing up on the YouTube video. Okay? If the audio chops, though, it will be chopping in the YouTube video too. Because this is not being recorded locally here at my laptop. It's being recorded on Blackboard over the network. So 2 sine 75 divided by sine 20. What do you guys get? Real estate. What do you guys get? 5 sine 75 over sine 20. 1412? Okay. Yeah, let's write that as 1412. Bunches of people got 1412, so that works for me. Now, we're missing an angle, aren't we? We can find that other angle, can't we? What's the other angle, guys? What's the other angle? Angle A plus B plus C have to add 185. Anthony got it right. Yeah, Elizabeth says 85. That's good. Thank you, Elizabeth. That's awesome. That's awesome. 85, yeah. Mario's got it. That's good. Yeah. So it's 95, 180 minus the 95 that you see is going to be 85, yeah? All right. And so now we're ready to do another crisscross. You can do a crisscross with a 1412. I recommend against that because there's always this chance that you're going to have an error compounding to an error. If you work entirely as much as possible with the numbers that were already given, then you're unlikely to come up with a more problem. You won't have one error causing another error. Okay? So here we go, guys. This time the formula looks like coming across, I see B sine A equals A sine B. Altitude, altitude. Okay? And this time I'm solving for A, little a, that's the length. And so that looks like B sine A over sine B. And now I'll fill it in. The length of B is 5. And we're going to multiply that by the sine of 85 degrees. And divide by the sine of 20 degrees. Calculators, guys. 5 sine 85, close it, divide, sine 20 equals. Okay? And if you don't get, yeah, that's the number I'm getting too. 1456? Yeah. 1456? Yeah. I'm not sure if I announced that in here or not. Okay, I should mention what I'm saying I didn't announce. I'm not sure if I announced it in here or not. But yeah, I'm not going to see you guys until God knows when. Yeah, that's right, Patricia. And so if I gave you a calculator for the term, it's yours for life. It's my gift to you. Because there's just not much I can do about that. Okay, so here we go. So that's 1456. Now we're almost finished, guys. There's one more check I want to do. Okay, guys? Look at the angles. Oh, you're welcome. That's okay. Don't worry about it. Yeah. Makes up for not being able to give you guys the pizza party I expected. Well, not quite, because I still want to give you guys a pizza party. I just can't figure out how I can do it. I'm not sure I can do it, how I can give you guys a pizza party. Okay, but I can give you, well, some of you guys got a calculator out of it. Okay, guys. A coupon. I could do that, I guess, yeah. Okay, guys, look at this. Angles, smallest to largest. I want an order of the angles from smallest to largest, guys. What is it, ABC? Smallest, largest, ABC, right? No, what is it, really? Order the angles from smallest to largest. What's the order? BCA. Very good. Okay, guys. BAC. BCA. That's right. Yeah. Okay. Now, guys, is what order the sides from smallest to largest? Also BCA. BCA in the angles, BCA in the sides, and that's something we always want to double check. It's a really easy double check. It's not guaranteed or anything like that, but it always has to be the case that the biggest angle is going to be opposite the biggest side. And if you think about it, just hold your arms out in front of you, start opening your arms for a bigger angle. And you can see the length between your fingertips is going to get bigger, right? If I was in class, you'd be seeing me actually doing this. But yeah, if you hold your arms out right there just in front of you and just open them up for a bigger angle, you'll see you get a bigger side, don't you? Yeah. So that's a double check you should do on each of these problems. Okay? So let's look at the next problem. Okay, guys. Law of sines, law of cosines. You tell me. I can't fool you twice. I fooled Daniel. It's okay. I feel good. Okay. And the answer is, yeah, Patricia, look at this. This angle we actually have because we got the other two. Yes, I know. I fooled you twice in a row. I feel so evil. Yeah. There you go. There you go. See, when I was your age, we had this expression. And what it meant right there is like when we were just kidding, we said just kidding. And now kids use it for a lot of other things. Joshua said, "Yep, that caught you twice yesterday, last time." But this isn't about catching you guys. This is about, letting you go ahead and find the errors, and then you'll remember it the next time. That's the idea, okay? So what's that third angle that we're missing? What's the third angle, guys? Third angle. What's the third angle? What's angle C? 75, 75, 105 is 75 away from 180. Yeah, 75. There you go. 75 degrees. There we go. Now, we are ready to rock and roll on the law of sines. And to make the law of sines work, we're going to start in some altitude equals altitude stuff. And so I see 1, C sine B equals B sine C. And then we'll do the same thing with C and A. That's the way it should work, right? And the first thing is I want to solve for B. And so B is going to be C sine B over sine C. Now we're ready to plug numbers. 9 sine 55 degrees over sine 75 degrees. Yeah? Okay. Let's plug the calculator to see what happens. Oh, I was going to ask if this was ambiguous. Did I remember to ask you guys if this is ambiguous or not? It doesn't matter because we're kind of past now. But yeah, we had two angles, so it's not going to be ambiguous. Yeah. Okay. So 9 sine 55, close the parenthesis, divide sine 75. And I get 7.63, 7.63, 7.63. Just by coincidence or something like that, that's the number that comes up on my calculator too. So it looks good, okay? Yeah. And now we're gonna do the same thing. We're gonna do the same thing for A, right? And so we're gonna see A sine 75. I'm breaking my rule, but it doesn't matter that much. A sine 75 degrees equals 9 sine 50 degrees. So A is going to be 9 sine 50 degrees sine 75 degrees. You give you permission to do what that was. Okay, so we got to plug in. Let's plug in. 9 sine 50 divide sine 70. And other people rounding to 2 because that's what we're doing in decimal places. 7.14. Okay. Right, because I have 2 decimal places, which are 2 significant digits. But yeah, whatever. 7.14. Let's fill those in. Let's fill those in. 7.3 for B. And 7.14 for A. You notice those numbers are really close together, right? Do you notice the angles that are opposite them are also really close together? Okay, and last thing we do, small to large, okay? On the angles, what's the order small to large? ABC. And on the sides, ABC, does it check? Does it check? Yeah, that's what we're looking for. Yeah, yeah. And that's a nice little double check. And it's really easy because, like, as you're moving back and forth on the other sides right there, to make some minor error and you plug in the wrong number in the middle of your process. And this will catch that. Sometimes. Most of the time, actually. But that's the idea. Okay? Now, let us move to the next problem. Okay? Law of sines, law of cosines, guys. Law of sines, law of cosines. Sines, sines. Everybody says sines. Yeah, law of sines. Law of sines. There we go. Okay, so is this the ambiguous case? Is this ambiguous? Ambiguous for one? Yes. And it's ambiguous case. Okay, so we're in the ambiguous case and we got to start our flow chart, okay? What's the opposite here, guys? I'll toss a hint. What's the opposite side? 10, yeah? Okay. Everybody sees the opposite side is 10, right? I'll zoom in so you can see even better, right? My first question, is the opposite greater than the adjacent? Is the opposite greater than the adjacent? Yes, perfectly with his perfect hair. Yeah. Yes, it is. And that's what we like. That means we're only going to have one answer. We're only going to have one possible triangle. Opposite's greater than adjacent. One triangle. Okay? Which is nice because you got less numbers to solve for, right? Okay? So here we go. We're ready to rock and roll, right? Okay. So we're going to find angle C, and that's going to be the right answer. Okay. We're going to find angle C. From your calculator is going to give you the right answer. And we'll use that to find angle A, and then we'll use that to find side A. Okay? So first of all, I know that 10, looking at my crisscross, sine of the angle C is 9 sine 55 on my crisscross degrees. And that tells me the sine of angle C is 9 over 10 sine 55 degrees. Okay? And so that tells me that C is the arc sine of 9 over 10 sine 55 degrees. Okay? So let's calculate that. I hit the second button in the upper left, and the sine button gives me arc sine. Now 9 divide 10 times sine 55. Okay? And I'm seeing 47.49 like that. 47.49. Okay. I'm going to hold that as 47.5. Okay. Yeah, that's what I'm seeing too. So the calculation's working? Good. Okay. Now we have that. So let me just fill it in. And from that, we should be able to tell what angle A is. What's angle A now? What's angle A? calculate angle A now. We got 2, you need the other 3, right? So I'm going to my calculator and saying 180, 80 minus 55 minus 47.5, because we're just rounding it, is 77.5. Okay. Yeah, that's going to create a limit on the degree of accuracy we have for A. But now we can find A, right? We locked it down. So I know that A, and we were given all the B stuff, so let's go for crisscross with B stuff. A sine B is B sine A. We could do it with angle C and side C, but because we were calculating at least one of those, I want to work with the numbers that we were given. So A is B sine A over sine B. Plugging numbers in, B is 10, sine angle A is 77.5, and angle B is 55. Okay, and now let's calculate that. See what it says. 10 sine 77.5, close it. Whoop. And I noticed a typo in my input. So I went back and fixed it. Sine 55. Okay, and people saying 11.91, 11.92, and I'm saying 11.9. You know why I'm going to say 11.9? Do you know why I'm going to say 11.9? How many digits did I keep for the angle? How many significant digits in the angle? 1, 2, 3. How many significant digits in the answer? 1, 2, 3. If I kept 4 digits on the angle, I'd accept a length that has 4 digits on it too. Okay? But the usual rule is, you know, as soon as you drop down to 3 digits, you're done to 3 digits. The 4th digit's not going to be meaningful. Okay? And I actually design exercises to show that on occasion. But that's good. Now remember my check, right? Small to large, C, B, A, yeah? Is that checking? Is that checking with the lengths on the sides? Looks like to me. And so we had a double check that looks pretty nice. Okay, cool. Thank you, Patricia. Alrighty. And we're kind of like slashing through these. This is pretty good. I got 14, 13 minutes or so, but that's okay. Okay, this is obviously the law of cosines, right? Yeah. And this is the law of cosines form where we're going to solve for the angle again, right? And so let's go for this. Angle A, or I should say the cosine of angle A, okay, is going to be the other two, 8 squared plus 9 squared added, minus this one squared over twice the others. And that's the way you think of it. Don't try to think about like what's the point and here's the formula. It's the other two squared minus this square over twice the others. Okay? And so I'm going to take the arc cosine of that thing and see what happens, okay? The previous one I had you calculate the cosine just directly, but this time I'm going to take the arc cosine of this. Okay, because the last one that I did force you guys to do the arc find the cosine, because I was trying to see if you'd see that the number was too big. But now I'm just going to go ahead and just do it. And recognize if I get a domain error, the problem is that some kind of triangle inequality issue. So remember, when you're calculating this one, there's a really easy ways to make the calculation go wrong. Remember, you want parentheses around the numerator, and then parentheses around the denominator also, to make sure you don't end up with order of operations issues. 8 squared plus 9 squared minus 6 squared, close the parenthesis around the numerator, divide, open a parenthesis for the denominator, 2 times 8 times 9, close the parenthesis. Okay, I got an answer here. And y'all tell me what you think. Yeah. Because I'm thinking about these all the time, I'm expecting this answer to be less than 60 degrees. Okay? I'm expecting this answer to be less than 60 degrees. Can anybody tell me why I'm expecting that? Are people plugging this into their calculators yet? What's the number? Let me get it closer so you can see it. You got 40.8. That's less than 60 degrees. That's what I'm getting to. I'm getting 40.8. Okay? Yeah. The reason I was expecting, and I'm expecting angle C to be bigger than 60 degrees, if that helps for the hints. Okay? I got 3 angles, yeah? They have to add up to 180. They have to average 60. The smallest should be less than 60, the biggest should be bigger. That's my thought. Because they have to average 60, right? Because there's 3 of them adding to 180. So the smallest should be smaller than 60, and the largest should be bigger than 60. That's another thing I do is just as a kind of working with it. But let's go ahead and set up the other ones. This is the R cosine, the other two. The other two this time are 6 and 9, yeah? This time the other two are 6 and 9, and this one is 8. So I'll say the other two squared minus this one squared over twice the other two. All right? So this time I'm going to take the arc cosine and open a parenthesis for the numerator, an extra parenthesis I should say. 6 squared plus 9 squared minus 8 squared, close the parenthesis on the numerator, divide, open the parenthesis for the denominator. 2 times 6 times 9, close the parenthesis on the denominator, and get an answer. Daniel is quick. That's the number I get, Daniel. Looks good. Other people getting that? And if you don't get that, I need to talk to me right there, because I know there's just standard things that happen wrong on these when you're plugging the calculator, and almost always have with putting in the right parentheses. Now point out that when I plug this in, this is what it looked like when I plugged it in. This is like the keystrokes. Here's the keystrokes when I plug this in. Arc cosine, and when I said arc cosine, it opened a parenthesis for me. And so I opened another one for the numerator. And then I used the square key. And then I used the square key. And then I used the square key. Then I closed the parenthesis on the numerator. Then divide, open a parenthesis for the denominator. 2, hit the times, hit the times, close it. I stopped there. I actually didn't even have to close that parenthesis, last parenthesis. because these calculators close any pending parentheses when you plug in, you hit the equal button. Okay, and that's how those work. And yeah, I came up with 60.6 as well. And now we're going to do this last one two ways. First of all, we're going to plug in the arc cosine. The other two, 6 squared and 8 squared, minus this one squared over twice the other two. Okay? And see what that works out in your calculators, okay? So open a parenthesis for the numerator, 6 squared plus 8 squared minus 9 squared, close the parenthesis. Divide, parenthesis for the denominator, 2 times 6 times 8 equals. And I get an answer bigger than 60 degrees. Yeah. And Daniel's like quick with a glitter here. That's cool. 86. Yeah. Okay. Everybody's going to get that as they run through. That's fine. 78.6. And now I want you to add these three together. This, because of rounding, we might be off 0.1 degrees. We should not be off by more than 0.2 degrees. But it's possible for our rating to give us something other than 180.0. If I add these three together, what do I get? Plus 60.6, 40.8, plus 60.6, plus 78.6 is what? 180 even, 180.0. Yeah. So that's a check. I would be okay with 179.9. I'd be okay with 180.1. I would not be okay with 180.2. And again, ABC, ABC, right? So we're good with that. All right? I didn't have enough time to do everything, but this one to do. I'll give you a bunch of questions to get you out, but this one I'm going to do, okay? First of all, sines, law of cosines. Yes. Law of sines, law of cosines on this one, guys. 1 for law of sines, 2 for law of cosines. Yep. Law of sines. Ambiguous, not ambiguous. 1 for ambiguous, 2 not ambiguous. Okay. Now, next one. 1 for opposite greater than adjacent, 2 for opposite not greater than adjacent. 1 for opposite greater than adjacent, 2 for opposite not greater than adjacent. And this time I'm not putting the hint in there. Opposite is not greater than the adjacent. This time I'm going to label them. Now I'm going to label them. Opposite, adjacent. And we have opposite is not greater than adjacent. That means we need an altitude. And for the altitude, it's the crisscross, 17 sine 85. What is 17 times the sine of 85 degrees? Seventeen sine 85. What do you get, guys? That's the altitude. 16.9. Okay, guys. Opposite greater than altitude. Opposite greater than altitude. No, no, no. So the opposites thing that I needed to be bigger than the altitude, the opposite that I needed to be bigger than the altitude, the opposite of 14, the altitude 16.9. Can we get a triangle out of this? The opposite is 14, the altitude is 16.9. Can we get a triangle out of this? And apparently not, huh? You see what's happening here, guys? The opposite has to be bigger than the altitude. Remember, those are your two checks. Opposite greater than altitude, one triangle. If otherwise, opposite greater than altitude, two triangles. But if both of them is no, no triangles. Okay? And I ran out of time to do the two triangles solution. How could I am I actually out of time? Damn. Because I need to do that. I need to do that. Damn it, I didn't do that. How could I not have done that example? Okay, let me see here. Okay, how about this one? Let's just check this one really quick, okay? Let's check this one real close. It's law of sines, okay? Opposite greater than adjacent? Opposite greater than adjacent? Yes, no. Opposite greater than adjacent? No, no, no. Okay, the next thing we see is, let's find the altitude. 10 sine 10 degrees. What's that? 10 sine 10 degrees. What is it? 1.7. Opposite greater than altitude. Opposite greater than altitude? Yes. The opposite is greater than the altitude. We're going to get two triangles. Okay. So this is going to be B1, C1, B1, C1. No, that's B1, C1, and C1. And we also have an A. We also have an A, B2, C2, A, B, C. Working with the same figures that we were given. And I'm going to get you started on this. At the very least, we can find B1 and B2. Okay, for B1, guys, we'll use the we'll use the calculators to find B1. I know that 3, and I know I'm going a few minutes late, I'm so sorry about that, but I need 3 sine B1 equals altitude, that 1.7. 10 sine 10. So sine B1 is that 10 sine 10 that's probably still in your calculator, divided by 3. Okay? And you take the arc sine of that. Dan, you got an answer yet? got an answer for B1? Daniel, you got an answer for B1 yet? You're my fastest calculator. Yeah, the sine itself, the sine of B1 is around 1/2, yes. Yeah, okay, now what's the B1? Take the arc sine of that. That's the sine of B1. Now take the arc sine of that. Take the arc sine of that. That's fine. Take the arc sine of that. What do you get? Arc sine. 35.37. 35.37. Some people probably use 1.7 and you're going to get only two decimals accuracy. And that's what you probably use 1.7 to get the 34. But yeah, it's 35.4. 35.4. And now, what's the supplement? What's the supplement? 180 minus that is going to give you B2. Because your calculator is going to give you the acute answer, 134.6. Okay, and now you can calculate C1 and C2. Of course, I can do it the cheap way. What's B2? What's B2? 144, 134, what is it? It is 144. You did in your head, didn't you? 144.6. Okay. B2 is 144.6, right? Subtract A. Subtract A. What do you get? Subtract A. What do you get? B2 minus A. What's that? This is a trick. B2 minus A. B2 is 144.6 minus A is 134.6. That's C1. And you get the same thing by coming up to 80, but the same way around. B1 is 35.4. Subtract A. Yeah, that's a trick. That's a trick. But it works. Yeah. Once you have B2, you got C1. C1 is B2 minus A. And C2 is B1 minus A. But that's a trick. You don't need that. I will leave calculating C1 and C2 to you guys because I'm 6 minutes over. Okay? Yeah. Okay? And that right there, thank you guys so much for helping me out here and participating and put your calculators to use. And tomorrow I will have 5 triangles for you to solve as your second assignment for turning in, and it'll be due Monday at midnight, okay? All right, so guys, thank you so much. It's always great seeing you guys again. I'm going to end the recording.